Hello, my dear students. Now let us go with our next few problems. We'll even see why, because till now I think we have went with four problems, four different problems. Still, I just wanted to explain you two more problems, and then we'll wind up with this stresses and a part of stresses and strains. Then we'll go with our next concept. Now, if you see with the next problem with stresses and strains. Now here I have just given you a question. Now if you see with this question, the safe stresses has been given, which carries an axial load of 2.1 into 10 to the power 3 kilonewton is 125 meganewton per meter square. If the external diameter of the column is 30 centimeter, determine the internal diameter. What he's telling you, he has given us a p value here. He has given you about your external diameter here. He has given. He's asking us to find out the internal diameter. So fine. First we'll write with the given data. As I have explained you many times, please read the question 2 to 3 times and write the given data first. Now if you see sigma value here, he has given it as 125 meganewton. So I can convert this mega into mega is 10 to the power 6, so I can write it as 10 to the power 6 Newton per meter square. So similarly, value of P, which is nothing but the loading here he has given it as 2.1 into 10 to the power 3 kilonewton. So I can convert kilo is 10 to the power 3. So 10 to the power 3, 10 to the power 3 is 10 to the power 6 Newton. So similarly, we even have diameter. As here, if you see, we have it into a meter. So I have converted this 20 centimeter, 30 centimeter to a meter, which is 0.3 meters. Centimeter to meter. How much is 1 meter is equal to dash centimeter? It is 100 centimeters. So 30 divided by 100, if you do, you will get it as 0.3 meter. Then what we have to do? We have to calculate our internal diameter. We have external diameter. Yes. So this is our external diameter, which is nothing but in a hollow shape. If you see, we have a hollow shape, circular shape we have. So outer diameter we have inner diameter. Yes or no? Outer diameter here he has given, but the inner diameter we have to calculate. Yes. Now, so how can I calculate outer and inner diameter? Using my area. How can I find out my area? Area is given it as, previously we used to write as pi by 4 into d square. Yes. Previously we have written it as pi by 4 into d square. Now here we'll write it as pi by 4 into outer diameter minus inner diameter. Please be careful. If you have a hollow circular pipe or hollow circular material, then to find out the area of that hollow circular dimension, we have area is equal to pi by 4 outer diameter minus inner diameter. So outer diameter what we have 0.3 meter, inner diameter we don't have, so let it be like that only. So we'll keep inner diameter as d small d square only. But we know stress. What is stress? Stress is load upon its area. Yes, but we already know what is how much is stress. Stress we know it as 125 into 10 to the power 6 Newton per meter square. We even know loading is equal to P. P how much we have? We have 2.1 into 10 to the power 6 Newton. So here also you can see we have Newton. Here also we have Newton. So we have same unit. Fine. But area, if you see, area is pi by 4 into 0.30 square minus d square. So the only unknown here we have is d square, which is our internal diameter. So I can write sigma as 125 into 10 to the power 6 equal to loading is 2.1 into 10 to the power 6 by pi by 4. Area is pi by 4 into 0.30 square minus d square. So send this one to the opposite side. Here I'll send. So I'll bring this 125 into 10 to the power 6 down. Fine. And even I'll send this pi by 4 down. So we are remaining with 0.30 square minus d square. Now I'll send this d square there and I'll bring this one here. So 0.09 minus d square is equal to 213.9. So when you send, like when you simplify this one, so we have d square is equal to square root of 0.09 minus 0.1. So we have 0.2619 meter. If you write it into centimeter, we have 26.19 centimeter. Yes, I think everyone you have understood how to calculate internal diameter. So we'll go one more problem. That will be the last problem for this topic. Now, what is the next problem we have? A stepped bar shown in figure 1.6. I think you can see the figure 1.6 here. So this is the figure 1.6. A stepped bar shown in figure 1.6 is subjected to an axial load. How much is axial load we have? Axial load as 35 kilonewton. Now what we have to calculate? Find the maximum and minimum stresses produced. In which bar we have maximum stress and in which bar we have minimum stress. Now here if you see, we have two bars, a stepped bar. That is the reason here he has given. So this is one bar. So the diameter of that bar is 2 centimeter. Now below if you see, we have one more bar. So the diameter of the below bar is 3 centimeter. So we have to calculate in which bar we have maximum stress and in which bar we have minimum stress. So let us go with the problem. Now given data if you see, we know P value, which is nothing but our load, 35 kilonewton we have. So you can convert kilo to 10 to the power 3. Yes, and even we have diameter d1. So let us take the first one, which is 2 centimeter. Similarly you can take d2 as 3 centimeter. So if you calculate the area of the first one, area A1, I can write it as pi by 4 into d squared. So d I have converted into mm. So 20 square, which is equal to 100 pi. Now similarly, if you to go with your second one, A2, which is equal to pi by 4 into d2 square. So what is your d2? D2 is equal to 30. So here if you see 3 centimeter, I can write into mm. So 1 centimeter is equal to 10 mm. So I can write it as 3 into 10, which is equal to 30 centimeter. So I'll be getting it as 225 into pi mm square. So here I have just made a very clear statement. Please read this statement. The stress is equal to the load divided by area. We know that, yes or no? What is in by stress? Stress is load divided by area. Load divided by area, which means that stress is directly proportional to the load, but stress is inversely proportional to area. Yes, which means that if you have more area, you have less stress. If you have less area, you have more stress. Yes, that's what I have explained you here. Fine. The stress is equal to load divided by area. Hence, stresses will be maximum where area is minimum. Hence, stresses will be maximum in upper part and minimum in lower part. Why? Because once again I'll tell you, stress is load upon its area. Yes, stress sigma is equal to P by A. Yes, stress is equal to load upon its area. Then stress is directly proportional to the loading, but stress is inversely proportional to the area, which means that if your load has been increased, your stress will increase. Yes, if your load has been decreased, your stress will decrease. But if you take with your area, why? Because area is inversely proportional to stress. I'll tell you, if your area has increased, please be careful, it is inversely. If your area has increased, your stress will decrease. If your area has decreased, your stress will increase. This is inversely proportional. Yes, that is the reason. If you see with the first diagram here, 2 centimeter, the area is less, which means that the stress in the first 2 centimeter will be the more. Similarly, if you go with the like 3 centimeter diameter, whose area is more when compared with 2 centimeter. Yes, so the area is more, the stress will be less. Then I can tell that this 2 centimeter will carry maximum stress and 3 centimeter will carry minimum stress. So let us go with our maximum stress. Maximum stress is load upon its area. Now loading here he has already given 35 kilonewton. So 35 into 10 to the power 3 by area. What area I have to take now? I have to take my smaller area, 100 pi. So 100 pi is my smaller area. Then I'll get my maximum stress. So maximum stress here, if you see, we have got 111.408 Newton per mm square. Similarly, if you go with our next one, we have minimum stress. Minimum stress is again load, like stress is again load by area. Load we already know, it is 35 into 10 to the power 3. Area, now we have to take the maximum area, which is a bigger value between these two. Bigger value is 225 pi. So if you divide 35 into 10 to the power 3 by 225 pi, you'll be getting 49.54. So I think everyone are comfortable with the problems till now whatever we have dealt. Thank you. Hello. Hello. చెప్పనా. హలో చెప్పనా.